can. So what I would do on this first one is I would take this sign that's a 1 sign and I would add it to the other side. So it's like we're adding 1 sine x here, which would give me 2 sine x, because it's 1 sine x plus 1 sine x would be 2 sine x. At the same time, I'm going to subtract the square root of 2 to the other side. Okay. Remember, as a reminder from last Friday and last week, we are treating the trig, the entire piece of trig, like it's a variable. Okay. So we want to make sure that we are, that's acting like an x. So we're isolating the trig first. So the next thing I'm going to do is I'm going to divide by 2. So I get negative square root of 2 over 2 divided by 2. Now is when I'm allowed to get rid of the trig, and I am going to go on my unit circle. I'm going to find everywhere. Let's see, sine, help me out. Is sine the x value or the y value? I kind of forget this morning. X value or y value for the sine? Help me remember. Good morning, Samantha. Good morning, Andrea. All right, so it's definitely the y value, and it's nice to see a lot of you paying attention. I need to see more, though. It's not everybody. Okay, everybody should be participating in that chat for me, okay? All right, so I'm going to go for the y value. Every time I see the y value as negative square root of 2 over 2, I'm going to write down the radian measure. So I'm going negative square root of 2 over 2 looks like it's at 5 pi over 4, and at 7 pi over 4 are the two that I would write down. And as you're waiting, you know, for me, if I start babbling, you should be looking for those answers on your unit circle. You should always be like a step ahead of me, okay, if you can be. All right, that's how you know you're really getting it, if you can be 1 step ahead of Mrs. Ballard. Okay, let's try this again. So we've got cosine. What am I going to do to move this cosine to the right side? So what operation do I need to do? Add, subtract, multiply, divide. Help me out. I want to see everybody in the chat there. Okay, we are definitely going to add that over. Okay, it looks like we've got, I thought I heard an extra noise. Oh, I've got that at 100%. Maybe somebody accidentally raised their hand and put it back down. All right. Okay, so we're going to add this over to the other side, which means that I would have 1 cosine plus 1 cosine would be 2 cosine x. At the same time, I'm going to add the square root of 2 over. I've got a fly with a death wish in my classroom right now, driving me bananas. I have the fly zapper on. We'll see if we can get him by the end of class. Actually, what I should do is go turn out the lights since it's just me. I'm going to divide by 2. Okay? Let's cosine the x value or the y value on the unit circle. Tell me in the chat. X value or y value? Okay, I'm seeing a lot of x values. Perfect. Okay, I want you to do this before I go write it down. Everybody examine the unit circle. Find everywhere on the unit circle where the x value is positive square root of 2 over 2. Everybody go find it right now. See if you can get it written before me. Of course, the fly's going to like it here because there's a lot of light radiating from my station. Good morning, Michael. Maybe he'll go to the blue light is my hope. Okay. X value square root of 2 over 2. Looks like we've got it here. So pi over 4. Did you guys get that one? Pi over 4. I'm looking for another positive square root of 2 over 2. We've got 7 pi over 4. Good morning, Leslie. Okay. We're going to make it a little bit tougher now. Okay, I'm going to kick it up a notch. All right, so again, I'm going to treat the trig like it's a variable, okay? So we're going to add the 1 to the other side. So I get 3 tangent squared x equals 1. I'm going to divide by the 3, so that means I've got tangent squared x equals 1 divided by 3. Oh, this one's interesting. Okay, We're going to take the square root of both sides. Technically, when I take a square root, what am I supposed to write out in front? So what do I write out in front for a square root? What do you guys think? Yeah, we got to write a plus minus. So check this out. We're not going to just have two answers this time. Just think about what could happen here. So tangent of x equals, the square root of 1 is just 1, right? And then we'd write it square root of 3. So that means I need everywhere where I either have a positive 1/2 and a positive square root of 3 over 3, or a negative of each one of those. I need every time I have a coordinate, that's the square root of 3 over 2 and 1/2. Remember, tangent is sine over cosine. And when we're thinking about these, this is really the same thing as saying 1/2 square root of 3 over 2, but I don't know where the plus minus goes, okay? I'm going to write a little bit of extra work to the right, which I'm going to erase in a minute, okay? So if you want to write this down somewhere, you can. You don't have to, but I want to make sure you understand this concept. So that means my x coordinate is square root of 3 over 2, or it could be negative square root of 3 over 2. The y coordinate is positive 1/2 or negative 1/2, but it doesn't mean that those are my only ones. Couldn't I have positive square root of 3 over 2 and negative 1/2? Couldn't I have negative square root of 3 over 2 and positive 1/2? So I just got 4 coordinates out of that. So I need anywhere where I have that pair, where the square root of 3 over 2 is in the x and the 1/2 is in the y, which means I'm going to get 4 answers this time. So I'm getting 4 radian measures. So it looks like the first one is right here. So I'm going to write down pi over 6. I'm going to keep going. I'm looking for square root of 3 over 2 in the top, in the first part. 5 pi over 6. All right. I'm going to grab this one. I get 7 pi over 6. And I'm going to get this one, and I'm going to get 11 pi over 6. Is there an interesting pattern there? What's interesting about all those answers? Tell me in the chat. What do you think is interesting about all those answers? I'm going to erase all my coordinates here. Or you're telling me nobody knows what's interesting about the answers? What do they all have in common? They're in the same place, just mirrored. I like that. I like about the denominator, right? All the denominators were exactly the same. So there's a relationship between all of the denominators being the same, right? If we had gone back to our reference angle, remember when we did the reference angle or the reference triangle? All of those would have had a 30-degree reference triangle or a pi over 6 reference angle, okay? So all the over 6s is what we picked up on those. Interesting pattern. Okay, let's try example 12. Okay, so let's see. We'll use something else. We'll use blue. All right, so I'm going to add the 3. So 4 sine squared x equals 3. I'm going to divide by 4 over 4, and then we're going to square root both sides. When I square root again, you just told me I have to put a plus minus out front. So it equals plus or minus square root of 3. What's the square root of 4? Tell me in the chat, what's the square root of 4? Everybody should be able to answer that one quickly. What's the square root of 4? Not there yet. I don't have everybody yet. Okay, it looks like it's 2. Perfect. But this means I need everywhere where the y value is positive square root of 3 over 2 and everywhere where the y value is negative square root of 3 over 2. How many answers do you think I'm going to get? Am I going to get 2 answers? Yeah, when we have to include the pluses and the minuses, we're going to get 4 answers on this. Okay, so let's try to find them. So I'm looking for the y value we said. So here's the y value over 3. Pi over 3. I wonder if we're going to get that same pattern again. Up 2 pi over 3. Let's see. Oh, goody. 4 pi over 3. Same denominators again. All right, and then my last one is at 5 pi over 3. So all the same denominators again, this time with a 60-degree reference triangle. let you write for a second here. Oh, good. That doesn't have the answers. Give me a second. I got to pull up an older answer key here. 5, 3, 18 did not work very good. So I want to make sure I do them correct for you. Unit 3, Chapter 5. Let's see if that one has it. Example 13. Yep, okay. Let's take a look at 13. 13's a little bit uglier. 13's a lot uglier, actually. Well, it seems a lot uglier than it probably really is. The first thing I'm going to do is I'm going to try to get all of my trig to the left, just like we would do if we were trying to solve a quadratic, okay, or a polynomial equation. We get it equal to 0. So that's what I'm going to start by doing. So let's take this guy and we're going to move him to the left by subtracting. So cotangent of x cosine squared x minus 2 cotangent of x equals 0. Okay. I am noticing, okay, so I'm going to look at my yellow group here and my blue group here. Is there something that is in both groups? What's in both groups? What do you notice? What's in common in both groups? All right, some of us, not all of us, are seeing a cotangent. That's correct. So cotangent is common in both groups, all right? So that's going to be our greatest common factor, right? Because the first rule of factoring is take out the greatest common factor. So that's where we're going to start. So I'm taking out cotangent of x, and I'm left behind with cosine squared x minus 2 equals 0. All right, I know this is digging way back, but let's remember we had a property. Who remembers the name of the property that we had when we took quadratics and split them up and set them equal to 0? You get extra bonus stars today if you remember that property. Who remembers the name of that property? Anybody? Mariana, you've got it. And Nidaleen got it. So 0 product property. And Coral, you all get extra bonus stars today. Okay. Cotangent, you ready? Actually, I will give you extra bonus stars. Okay, right now. Let's do that right now. We'll call it extra bonus confetti. How's that sound? So you all get the confetti today. So this is in honor of everybody who gave me 0 product property. Okay, there you go. All right, we deserve confetti for remembering that, right? That's a big one to dig out here on a Monday morning. Okay, so I am setting both of these things equal to 0. So I have cosine squared x minus 2 equals 0. Okay, so I know that cotangent is the cosine divided by the sine. Well, I need to know when the cosine, that's basically 0 over 1. That means the cosine, or the x value, has to be 0, and the y value has to be 1. But technically, I don't know if this denominator is a plus or a minus, because I would get the same answer. So I could get either one of those choices. So I'm looking for 0, 1, and I am looking for 0, negative 1. So I'm going to go back to my unit circle. 0, 1 is right here, meaning I get to use pi over 2 as an answer. So x equals pi over 2. And then 0, negative 1 is right here, meaning I get to use 3 pi over 2 as an answer. But that's just half of it, right? Because I still need to deal with the other half. So I'm going to go ahead and move my 2 over. So cosine squared x equals 2. And then I'm going to square root, technically plus minus. Cosine x equals, now here's a problem. There is not somewhere on the unit circle where I have square root of 2 or square root of 2 over 1. So this half doesn't produce a true solution. It's extraneous on that side. Okay, so I only get pi over 2 and 3 pi over 2 over there. All right, how are we doing on time? We get out at 10:03. Let me see what we have left here. We're at 13. Okay. I am going to skip over 14. So we can cross out 14. We're going to kind of pick and choose because 14 is identical to 13. So let's get rid of 14. And if we look at 15 and 16, they're identical. So let's just do 15. Okay. We are going to get in the ones we need to know, right? Okay. So, and that's good because we probably need the space for 16. Okay. For the number 15 here. So I want to know if that looks familiar. Wait, why did that? Okay, so Lauren, I'm sorry, I just looked up. And Annalisa's answer is right. It's extraneous. Okay, so remember for sine and cosine, and I know we haven't looked at the graphs a whole lot yet, but for sine and cosine, our answer has to be between 0 and 1. Okay. I can't have an answer that's not between 0 and 1. So square root of 2 is like 1 point something. So it's bigger than 1. We will probably, I don't know, I might do it next week, have us look at the graphs. I don't know, maybe we'll do it Wednesday. I haven't decided yet. Maybe it'll be our Wednesday task this week to look at the graphs a little bit. I usually have you guys play with them for a day, just so you understand what they look like. Okay, let's take a look at this one. So I want to know, does this look sort of like this? Don't they look identical except that I just plopped an X in or there was a sign X? Okay. We are not doing a test this week. Okay. So there's 2 more things that we have to do in the test. We haven't retested the last one, and we're going to test on the new material. Okay. I'm thinking that's probably going to be closer to finals week that we're going to do those 2 things because I'm going really slow through this stuff. I'm not trying to push it. I know you all have AP exams. Tell me in the chat, what AP exam are you taking? If you're taking an AP exam, tell me which one. Because those days, I'm going to probably go light. Okay, we've got a lot of laying. We've got Euros going on. Oh, Spanish. Alexis, I'm your proctor. Okay, we've got laying and psych. Alexander, I'm your proctor for Spanish. So I'm because Spanish is on campus. Has everybody gone in and looked at the app yet? Did you all get my message in Google Classroom and on Remind? You need to find that. So obviously AP Euro, I am not doing anything that day, anything major. I'm going to take roll and let you have, that was going to be a catch-up day, right? So we're going to get through as much of this trig as we can, but I'm not going to put tests on top of your AP exams. That's not fair. Okay, because my poor students, guess what's on top of their AP exam? Senior finals. So it's not fair to I don't think that's fair. Okay, we're not going to take a final. We're going to do what we did last semester. If you've got an A going in, you have to take if we haven't taken the test on this unit yet, you got to take that one, and then I'll probably let you make one up. Okay, does that sound reasonable? Okay, we're not going to we've had a year, haven't we? We don't need to stress about final exams at the end of the year, I don't think. Okay. All right, Mario's super excited about that. So is everyone else super excited that I'm not going to give a final? I think at this point it's ridiculous. So, all right. So if we were here in school, yeah, I'd probably give you that experience, but I don't see it necessary. And next year, when you take calculus, there's no final, at least second semester. I don't ever give a final in calculus second semester. So I've only got like 5 people excited about no final. So I guess everybody else wants to take one. So, all right. That's our brain break. Is that a good one? No, Annalisa says no, we aren't taking one. You were one of the people that said yes, so you wouldn't have to. Okay. Let's go back to this example. Okay. Oh, did I tell you the other thing? So I said we're going to take those tests, but the other thing we still have to do again, you guys remember it was like September, we took the MDTP. We have to do, it's kind of like a map test. Okay. Don't let the others convince me. It was kind of like a map test for middle school and elementary school. So we have to do that again. But I'm thinking of doing it like on Wednesdays, maybe. I know I need to look at the calendar and when your AP tests are here, and then we will start working through that. So I might give that, maybe I'll give that during AP test week, just so it's a little bit lighter on homework that week. Okay. So, but we've got to get that done when you guys are in class. Okay. So I'll look at the calendar and I'll let you know what days we're going to do that. okay? But this is really good review because guess what's going to be on that test? It's not going to be trig, it's going to be algebra 2. So we're going to do this. We're going to review our factoring. Doesn't that sound like fun? We love factoring, don't we? Okay, so here we go. So we've got the good old magic X going on because it's a trinomial. And remember, I multiply the first one and the third one together, so we get -2. And then in the middle, we write this number that's in the middle, so -1. So help me out in the box in the chat. Two numbers that multiply to -2 and add to -1. What do you think? Two numbers that multiply to -2 and add to -1. What do you all think? Everybody should be able to help me with this. Okay. We've got -2 and 1. I'm seeing a lot of that. So -2 and 1. Do I need a box? Do I need a box? Better yet, why do I need a box? What's the reasoning behind the box? Why do I have to use that? Wait, and I don't see everybody. I've lost some people. Hope you all are still there paying attention. This stuff's important. All right, I've seen a lot of leading coefficient. We do need a box. We have to use it because it has a leading coefficient. Okay, so here comes my box. I shouldn't have probably, I know what I'm gonna do. I'm gonna draw it to the side so I can do my work underneath there. I'm gonna draw my box here. Okay, so the top left-hand corner, remember, is 2x squared. I wrote way too close to the top there. And my bottom is -1 right from here. And then my other two numbers come out of the box with an x followed by them. And then I ask myself, what times what's 2? 2 and 1, right? There's no choice. 2 divides into 2, not into 1. So I'm going to put my 2 on the side, my 1 on the top. And I ask myself, how many times does 2x divide -2x? It's -1. How many times does 1x divide 1x? It's 1. And 1 times -1 is -1. You have to know that if you're taking calculus next year. I'm not teaching that to you next year. We're done with that. Okay? All right, so really when I factor this one with the x's, I get x minus 1 times 2x plus 1 equals 0. That wasn't what they wanted us to do. They wanted us to put signs in there. So instead of x, I'm going to plop sine in there. So I've got sine x minus 1 times 2 sine x plus 1 equals 0. But hopefully you can see how you can take it a step back and go, ooh, I can just use algebra, right? Use my x's in there, figure out the factoring, and then put the trig, plop the trig back in that I need to do. Okay, zero product property again. Okay, and then we're doing unit circle work. So it looks like I've got sine x equal to 1, 2 sine x equals -1, and then divide by 2. Okay, so on each one of them, we're down to like 1 or 2 answers. So I'm going to my unit circle. Okay, is sine the x value or the y value in the unit circle? One more time, I want to make sure you're paying attention. X value or y value? Okay, I see the y value coming up. I see some new people who are participating that don't normally participate, but I see some people who usually participate that aren't participating today. I hope you're all there. Okay, because remember today's lesson, this one, these 2 days, there we go. I got the 2 that I was looking for. All right, these are important. We have to be able to do this for next year. Okay, there is no choice. Like if I didn't teach any of the other trig lessons that are in this unit and we just stopped here, we'd be okay for next year. Okay, all right, we're gonna dabble in some of the others. The next one in line is kind of fun. All right, I've got a good lesson that goes with it. I might save it for your class for Friday because it's fun and there's a lot of people here on Friday. All right, we've got 1 and the y value. All right, so I know that 1 in the y value is just pi over 2, and that's the only place I have a positive 1 in the y value. So I'm just going to use pi over 2. All right, and then -1/2 in the y value, I know that's got to be in quadrants 3 and 4. So 7 pi over 6 and 11 pi over 6. So in this case, we have 3 answers. All right, let's see what else we got here. My goal is to be at about 20 by the time we ended today. It looks like we've got repeat kind of examples. Sine, cosine, yeah. All right, let's see if we can get through 17 and 19, and I think we'll be okay. All right. These ones aren't on today's assignment. They'll probably be more on tomorrow's, but I want to make sure we've exposed you to everything we can since I've got the time. So let's get rid of 18 and get rid of 20. Okay, does that sound good? And we'll try to get through 2 more before the end of class. Okay. All right. Before I try to use the factoring, so we're going to add one more step. Okay, we're going to kick it up one more notch. Okay. I need to figure out if I can, I can't factor something that has sines and cosines. I need to get it down to one or the other. The only thing that would create any kind of movement in this or any kind of replacement is sine squared. So if I went back and I looked up at my pink sign, right, which I'm not going to scroll up to right now, I know that sine squared plus cosine squared, what's it equal to, everybody? Do we have that one memorized yet? What's sine squared plus cosine squared equal to? All right, a couple people are saying 1, good. Now, if I want to replace sine squared, I could just move cosine over, right? So sine squared equals equals 1 minus cosine squared. So that's me not really using my sine. I know sine squared plus cosine squared is 1, and then I manipulated it. I moved it over. So I'm going to take this and replace it for sine squared. So I've got 2 times 1 minus cosine squared x plus 3 cosine x minus 3 equals 0. I'll rewrite that because it looks a little bit weird. Okay. What does instinct kick in and tell you to do with that 2? What do you guys think we should do? I want to hear from everybody. Everybody knows how to do this. There we go. We are going to distribute. That's right. Okay, so I'm going to distribute this in. So I've got 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. I am going to combine my like terms because I can put this with this, right? And I know it's kind of a pain of a step, but we're going to do it anyways. Negative 2 cosine squared x plus 3 cosine x, and then that would be negative 1 equals 0. So there's one thing I don't like about this. One thing that's making me nervous. Who knows what's making me nervous about this, what I don't like? When we try to do a magic x, even with a leading coefficient, what do we not like in front of that leading coefficient? What do you think? Yeah, we don't like that negative, okay? That negative is terrible in front. Even though we know we got to do a magic x, we know we got to do a box, but we don't like that negative. So what I'm going to do is there's an easy way to change it. We just multiply everything by negative 1. Basically, that means I'm going to flip all of my signs, including the sign on the 0, which is just going to be a 0, right? So the 0 part doesn't matter. So I'm going to go positive, negative, positive, and then technically negative, but what does it matter on 0, right? Okay, so that's looking a lot better to me. If it helps you to go to this, 2x squared minus 3x plus 1, by all means, you can do that, okay? All right, we are going to go ahead and do our magic x again. So help me out in the chat. 2 numbers that multiply to 2 and add to negative 3. What are they? Multiply to 2 and add to negative 3. What does everybody think? All right, I'm seeing a 2 and a 1. Oh, Nadaline's brain grew. Good job. All right. Should be negative 2 and negative 1 would add to negative 3 and multiply to positive 2. All right, I kind of already gave away that we're going to have to use a box because we've got a leading coefficient. So 2x squared and 1 and then negative 2x and negative 1x. And then I ask myself, what times what is 2? And we would say 2 and 1, Mrs. Ballard. So 2x here and 1x here because it's got to divide into the negative 2. Net 2x times negative 1 would be negative 2x. And then 1x divides into negative 1x negative 1 times, and we check it. Negative 1 times negative 1 is 1. Instead of writing this with x's, though, I'm going to go ahead and write it with cosines. All right, so we have cosine x minus 1 times 2 cosine x minus 1 equals 0. All we've done is added a few layers on, right? All this stuff we've known how to do. We're putting together factoring with solving a trig equation, okay? Look at how awesome and sophisticated you are now, okay? If I gave this to the AB students right now, the AB Calc students, they might not be able to do it because I'm not sure how much of it I really did with them, okay? So think about this. You guys are going to be like way more sophisticated than they are. So cosine x minus 1 equals 0 and 2 cosine x minus 1 equals 0. You guys don't even understand how huge it is that we've gotten through almost our entire curriculum this year, and you guys have kept up. It's amazing. So the other, like algebra 1 through algebra 2, not so much. They chopped a ton. So you guys have done awesome. And then I'm doing the work, right, not talking about it. So I'm just doing the little bit of algebra that we know how to do, right? So I added the 1 for the first one. I added the 1, and then I divided by 2. Give you a minute to catch up with me here. All right, we're back on that unit circle, aren't we? Back to the unit circle. So I need to know where the x value is positive 1, and I believe that only happens here, which is technically at radian measure 0, right? So I know that x equals radian measure 0. Notice that the 2 pi part is not included, so I would not include that in my answer because it's got the parentheses. All right, I need 2 places where the x value is positive 1/2. So I notice one of them is at pi over 3, and one of them is at 5 pi over 3. So pi over 3, 5 pi over 3. I'll blow that up for you. Okay, we're going to look at 19 as the last one we're going to do. 19 has an extra little trick into it. Okay. One last one, okay, and then I'm going to let you go. All right. So on this one right here, there is not a whole lot I can do with just a sine and a cosine with nothing that's squared on it, right? I can't turn it into a quotient identity. I can't do a whole lot with it. So I have to find a way to create it so that I can get rid of either the sine or the cosine. So I can do the factoring thing like we've been doing. So one other technique that we can use is we can choose to square both sides, which for the right side is great. I know that sine squared, because of earlier, right? Sine squared plus cosine squared equals 1. So so sine squared equals 1 minus cosine squared. So I'm just going to substitute that in. 1 minus cosine squared x. Perfect. The downside of the left side is that I have to FOIL. I cannot just square the cosine and square the 1. That doesn't work. When I square an entire side, I have to put parentheses around it and square it. So the good news is we cross this one out so I can write a little bit of scratch work over here. Oh. Excuse me. Oh, so cosine, we're going to FOIL, and we have to do all of FOIL. Okay, so cosine times cosine would be cosine squared x, okay? Then we've got cosine times 1 would be cosine, and 1 times cosine would be cosine, so I have 2 cosine x in the middle. And then for my last, 1 times 1 would be 1. Okay, we ready for the next piece yet? All right, so the next thing I'm going to do is I'm going to get everything to the left side. So to do that, I'm going to start by subtracting 1, which, what do you know? Look, 1 minus 1, or negative 1 plus positive 1 minus 1 is going to be 0. I'm also going to add the cosine squared. So one cosine squared plus 1 cosine squared would be 2 cosine squared x plus 2 cosine x equals 0. Equals 0. Okay. All right. The next thing we're going to do, what do you guys think we should do? What's the very first thing we do? First rule of factoring. It's the very first thing I look for when I factor. Very first thing I look for when I factor. Oh, good job. Some of us remembered that we've got to do a greatest common factor. So greatest common factor would be 2 cosine x, and then that's going to be leave behind cosine x plus 1 equals 0. So let's see, that's going to do zero product property. 2 cosine x equals 0, and cosine x plus 1 equals 0. Okay. All right, then we're going to go ahead and divide by 2. So 0 divided by 2 is 0. And cosine of x equals -1. So is cosine, help me out, is cosine the x value or the y value on the unit circle? Okay, one last question for the day. You ready? So I want you to find the angle measures. So find everywhere where the x is equal to 0 and write it down, and everywhere where the x is equal to -1 and write it down. Okay, write it down. Don't type it in the chat yet.